So the complexity for the brute force method is 40 into 2 raised to power n into n. Why n into n? Because for every possible priority list, every possible hat, we are checking for all the possible combination with other, right? So the complexity is 40 raised to power 2 to 40 into 2 raised to power n into n, right? So how we can optimize this? Let's try to understand this. Okay. So if we look at the constraints, it tells us like n should be maximum 10, right? N should be maximum 10, and n should be less than equals to 40, and hat, we know that hat is less than equals to 40, right? If we look at constraint properly, can we like we understand like at each point we need the visited list, which will basically tell us like how many possible, how many possible students is already done, right? So suppose we are at any point and we want like student 1 is done, student 3 is done, student 5 is done, right? And we want to maintain this list at every point, like when we are collecting and calculating all the possible combinations. We want at each and every point what is the possible visited list at this particular point. That's why when we are getting, like suppose I'm at number 3, and now here I got to know that S1 comma S2 is already done. Now at hat number 3 I am iterating through 1 and 2. So when I just reach at 1, I said like 1 is already done, so it will not include in my answer. Similarly at this particular point, when I go to 2, it will say like it is already done, so we don't include it in our answer. So at each and every point we need a visited list, which basically tell us like what is done or not done. So that's why we compare with that list and we will say like it will add up to our answer or not. So why not create a visited list as a binary number? Suppose, so let's create this. Suppose we have a binary number 1 0 1 0, like this only, right? So suppose these points will represent the students S1, S2, S3, S4, S5, right? And maximum we have 10 till less than, right? Suppose this is a binary number. So if it's 1, it means already visited. If it's 0, it means it's not visited. So at any point we reach to any hat, which will basically tell us like I can S2 can be a me, then we can simply say okay, add to our answer and make it 1, right? At any point if we ended up in that situation, right? So let's try to understand this for this particular case. When we at hat number 1, we say our answer will be 0 0. So there is only 2 students, so it will be 0 1, right? This is our visited list. Now we are reached at hat 2. It will say now it's again 0 1, so we can't do anything. So when we reach at third hat, it say I can become 0 1 or I can become 1 1. Why 1 1? This because 2 is there in the list of this, right? So it will basically make this 0 to 1 at second position. That's why. So whenever this both become 1, we say this is our answer, right? So at this point we can say this is our answer, right? Similarly, if you start with 2, at first it becomes 0 1. Now at next when we go to 3, we say I can become 0 1 or 1 1. This with the help of 1 and this with the help of 2. So I can say okay, this is done. We have all the possible bits as 1. All the bits are set. All bits are set So it's answer. Okay, so we are using this binary bits here to maintain this visited list. As you know, maximum there can be 10 possible students, so our list size will become to maximum 2 raised to power 10, that is I guess 1024. So if we trace through each and every possible head, that is 40, at each head we find all the possible scenario, like all the possible scenario. They can be 1024 scenario, right? They can be total 1024 scenario. So this is our overall complexity if we try to achieve this with the help of this binary thing, right? Okay, so I think it will make sense to you. Let's try to understand the code of this, and after that I think it definitely make you more sense, like how we are going to achieve this.